Hey, fourth and fifth graders. I hope that you enjoyed building the circuits from diagrams for yesterday's science class. And today we're going to quickly review the schematic diagram symbols, and then we're going to learn about a new part of a circuit and the symbol that goes along with it. Let's really quickly review the symbols from yesterday. What does this one mean? If you said battery, you're right. All right, how about this one? If you said light bulb, you're right. And last but not least, the toughest one of all. If you said wire or other conductor, you're correct too. A few of you got fooled in schematic diagram D. Let's see if I can find that really quickly here. So when you looked at D, a lot of you predicted or even said it would light after you built it. But remember, when you're looking at the symbol for a battery, you have to pay attention to which way it's facing. So if you look really closely, the negative side is sticking off into space. There's nothing connected to the negative side of this battery symbol. So if you have a circuit that's only attached to the positive side of a battery, is it truly a circuit? Are the electrons actually going to go in a loop? No. So double check your work for D yesterday. If you got fooled from that one, that's okay. We can all make mistakes, but just make sure you learn a lesson from it to look closely at the symbols in the future so that the battery is actually connected to the rest of the circuit on both sides, so the electrons can actually flow from the negative side of the battery in a loop to the positive side. So that's just a little thing to check from yesterday. You did not have to send in your pages from yesterday. You just needed to show them to a grown-up in your house. But a few people chose to send them to me anyway. And from what I saw, you guys seem to really understand how to read those circuits. And every single person I saw the work of recognized right away that C was not a safe circuit to build because it would create a short circuit and the electrons would move far too fast through the circuit because there was no light bulb filament to slow them down. So good job recognizing a short circuit right after you learned about it. Today, we're going to be learning about a new part that's in almost every real circuit in real life, but we haven't really been including in our circuits very much. So in this simple circuit, and that's literally what it's called, a simple circuit, because it only has one power source and one thing to power, like a light bulb. It would also be called a simple circuit if it had one power source and a motor, or one power source and a heating device. As long as it has one power source and one thing to power, and that goes in a loop, we call that a simple circuit. And so when you have that simple circuit, it's a circuit no matter if it's closed, where their wires are connected and the job can actually be done, or if it's open. So we still call that a circuit either way, but there's usually something in real circuits that helps them close and open more easily, so you don't actually have to hold real wires together or twist them. It's safe to do that with this type of circuit, but can you imagine if you had to do that with a circuit coming from a wall outlet that used 120 volts of electricity, not just 1.5 like our little batteries? If you actually had to touch the wires and twist them together or hold them together, that wouldn't be safe or practical. So electricians designed something to close the circuit when people wanted it to be closed and have the power go through it, and open it when people didn't want the power to go through it. Can you think about what that's called? Let's draw really quick the schematic diagram for that simple circuit over there. So I would start with the battery, that long line and a little short line and a plus symbol, positive symbol. and then a little shorter line and a negative symbol, the minus symbol. And then the wires come out, and I think the wire was kind of longer on one side, and my light bulb was coming out of the battery with its short wire connected to its actual little light bulb. So a little light bulb symbol, and connecting that on both sides. There. So there's my schematic diagram for the simple circuit I was just holding up a second ago. But what do people have on real life circuits to open the flow of electricity and close it? Can you think of something? If you said a switch, that is right. So when inventors and designers are figuring out their circuits, they put a switch in it. And the schematic symbol for that is a little dot connected to an arrow, and then showing a dot where that would get connected if someone were to put it together. My arrow's not very pointy. There, you see that a little better? So this is the official schematic diagram symbol for a switch. And that's how you would draw a switch. And switches look all different ways. There are so many switches in the world. Some switches you're most familiar with are light switches. So let's go see one of those really quick. Here's a few different light switches. So some light switches, you just kind of pop them on and off, click, click. Other ones use sliders to adjust how much electricity is going through. You can see my room's getting slightly darker and slightly brighter with that one. And there are lots and lots of other types of switches in the world and probably in your house. Some switches use buttons, some switches use knobs, some switches use little buttons like this. Sorry, didn't mean to blind you. And some switches only stay on and keep the electricity going through if you keep touching them, like a doorbell. Wouldn't that be weird if someone just pressed your doorbell one time and it kept ringing and ringing and ringing and ringing until they pressed it again, like the flashlight? So a doorbell is a type of switch that's designed to only close the circuit when the finger is touching it, and to open the circuit when the finger comes off of the doorbell. A lot of refrigerators have a switch inside of them that only opens the circuit when the switch is not being touched. So when you open your refrigerator door, the light comes on, and that's usually because there's a switch in there. And when the door is not touching the switch, when you open the door, the light goes on, the circuit gets closed, and the electricity can go through the light bulb in the refrigerator. And then when you close the door, then the little switch gets touched by the door and turns the power off and turns the light bulb off, so it doesn't just waste electricity when the door is closed and no one's looking in the refrigerator. My refrigerator doesn't have that type of switch, so I can't show you. But why don't you pause the video right here and go see how many different types of switches you can find for electrical devices in your house. That could be either switches that are attached to parts of your wall for lights or fans or other things built into your house. That could also be switches in appliances like refrigerators or dishwashers or washing machines, or switches in smaller devices like, radios and flashlights and electronic games. So pause the video right here. I'm watching you. Actually pause it and go look for some switches. Don't worry, I'll be here when you come back. You can press play again. Actually pause and go look for some switches. All right, welcome back. I hope you truly did take a little break from your screen and go search around your house for real life switches. During Perkins at Home, sometimes we can be stuck in front of our computer screen for a long time. And it's helpful to wake up your brain by getting up every once in a while, especially when there's an assignment that tells you to do it, and going to another part of your house or getting some fresh air. So I hope you truly did take a screen break. Remember how addictive screens can be, and go around your house looking for some real life switches. Write down all of the switches you found, the different types you found. Don't just say, I found a switch on my dishwasher. Say what kind of switch that was. Was it a knob? Was it a clicker switch? Was it a switch that you slide or a rope that you pull? What are the different types of switches you found on the different devices and appliances and wall outlets? So write a list of that, because that's one of the things that you need to turn in to me for this assignment, is a list of the different types of switches in the different parts and the different things of your house. So write down the list of all that you found, and then I'm going to tell you about the project for today. All right, are you ready for today's project? Today's project that you can work on over the weekend also is to make a simple circuit. So only use one light bulb and one battery, and you can use as many pieces of your wire as you want, and you can connect them in any order. You could have wires coming out of both sides of your battery and then your light bulb somewhere in the middle, or you could have it something like this, but don't use more than one battery or more than one light during this project. Just one battery, one light, and as many wires as you have available if you want. But the project, the challenge for today, is to build your own switch. Try to invent something that would make it easier and safer, if this battery had more voltage in it, to close and open the circuit than just twisting these wires together. Not very practical, not very simple, and if it had more voltage, not very safe. So you are hopefully going to be inspired by the different types of switches you found in your real house today and invent something else. You can use all sorts of supplies. You can use other types of conductors like paper clips, pieces of foil, little, metal rings, metal parts of clips. You can find other types of conductors. And remember, if you're unsure what a conductor is, you can look back at that page 5 of your inventor's journal where we did that station and you listed the conductors and the insulators. Remember, conductor means something electricity can flow through, usually some type of metal. And insulator means something that electricity cannot flow through, like plastic or rubber or cloth. So think about some of the materials that you could add to your circuit to make a really cool switch, so that you can both easily open and close the circuit and control when the power is running through it and when it's not. So it needs to be easy to use, and it needs to be safe to use if this battery had more voltage. So the part that you touch with your finger cannot actually be a conductor. So for instance, I couldn't attach this metal ring to the wire and then just have that loop to the other part of the circuit, because I would still be touching a conductor. The conductors are going to be helpful to be part of the inside of your switch, but think about a way that you can add something that's an insulator to the conductor part so that what you're touching is an insulator, not a conductor. Just like the light switches, I'm not touching the real wires, thank goodness. I'm touching a little plastic dial or clicky switch. When you have designed and built your switch, you are going to fill out the next 2 pages in your Electrical Inventor's Journal, starting on page 14. This is called the Switch Invention Spec Sheet, and spec is an abbreviation for specification, for specifying how you built it and what you used to build it with. So that's what the terminology inventors use to show their invention. It's called a spec sheet, which is short for specifications sheet. And you'll see that on your paper, it has you write who the inventors were. If you had a brother or sister help you with this, or a parent, you can give them a little credit here. You could always say that you were the lead inventor and they were part of your team. But this is to put anyone who's in your team and the date that you invented this on. You can make a little company logo, and then you're going to write all of the conductors that are in your whole circuit and the switch part of it. You're going to also write any insulators that you used and that are part of the circuit already. Also, there's already some insulators in here. And then down here, it says, draw your switch invention. Use a different colored pen or pencil to show where the current flows. So this is where you draw what it looks like in real life. You don't use the schematic symbols for this part. If you use a paper clip, you actually draw the paper clip. So draw what it looks like in real life in nice detail. And as it says, use a different colored pen or pencil to show little arrows that show how the current would flow through if your switch were closed. And then on the other side of that paper, it asks you to draw a schematic diagram of your switch invention. And remember, the symbol for a schematic diagram, wire, or any other conductive material is just the straight line. So whether you use a paper clip as one of your conductors, or foil, or even a little metal spoon, what you show in the schematic diagram will just be a straight line, because that straight line is for any metallic conductive material. So draw what your switch and the simple circuit that it's part of would look like with schematic diagram symbols. And then how does your switch work? What are the specific uses? What is special about it? Your switches can be any of the different types that you discovered in your house, or a different type you dreamed up. It can be one that stays on when you touch it and turns off when you don't. It can be something that slides or turns. All sorts of switches are a possibility for this experiment. So be creative and explain in this section after you've built it how it works, what you think it would be helpful for, like what kind of device or contraption, and then what's special about it. This is kind of your chance to also give a little advertisement, like why should people consider buying your switch for their device? Because inventors don't just always invent a whole device or a whole machine. Sometimes they invent part of it, like a special switch, and then they sell that to other companies or other inventors to put into their invention. So this is your chance to really explain why your switch is really cool and why it would be especially helpful for someone to consider to put into their machine or their device. So elaborate here. And then by Monday, you need to send me a photo of your whole switch and simple circuit put together, and a photo of both sides of your switch spec sheet, and that list that you made of all the different cool switches that you found around your house and what they're a part of. So those are your 3 things to do. But you get to start today, and then you have the whole weekend until Monday to turn those in. So they're due on Monday, and let me know through email if you need any help or any clarification on any part of this project. I can't wait to see your switches. Hopefully they'll be a lot more built up and interesting than my little random example. So good luck. Bye.